Welcome back to the channel. Today we're exploring some never-before-seen questions on the GED science. We'll explore key science topics like plate tectonics, chemical reactions, and earthquakes. Each section will enhance your analytical skills and build confidence as you prepare for your GED science exam. Let's get started. So let's start from question 1. As usual, they give us a short passage to read and then ask questions based on the passage. Plate tectonics theory suggests Earth's crust is made up of several large plates, moving slowly in different directions. When two plates collide, one can slide beneath the other, causing earthquakes and volcanic activity. A map indicates frequent earthquakes along the boundary between the Pacific Plate and the North American Plate. The question reads, based on the theory of plate tectonics, frequent earthquakes along plate boundaries are most likely caused by... And then it gives the answer choices. Now, I know this can be a difficult question to answer if you don't understand the concepts. Let's start by talking about plate tectonics. Plate tectonics theory suggests that Earth's crust, which is the outer layer of our planet, isn't one solid piece. Instead, it's made up of several large plates that are always moving very slowly in different directions. Imagine giant puzzle pieces shifting gradually around. When two of these huge plates meet, they sometimes collide, and one can slide underneath the other. This sliding action can lead to earthquakes and volcanic eruptions. For instance, frequent earthquakes occur along the boundary between the Pacific Plate and the North American Plate because those two plates are pushing and sliding against each other. Okay, let's break down this question together. The question asks, based on the theory of plate tectonics, frequent earthquakes along plate boundaries are most likely caused by... So, when a question asks about plate tectonics and earthquakes, it's really asking you to recognize that earthquakes usually happen because plates are either colliding or sliding past each other, creating pressure and eventually releasing it as an earthquake. Understanding this concept can help you identify the right answers in your GED science exam. You're given 4 choices to choose from here. A. Plates cooling down and contracting. B. Plates sliding past or colliding with each other. C. Plates dissolving into the ocean. D. Plates expanding due to heating. Pause here for a moment and think. Based on what we've just discussed about plate tectonics, what do you think causes earthquakes to occur along plate boundaries? Remember, plate tectonics theory tells us that Earth's crust isn't one solid shell. It's broken into huge pieces called plates that move slowly in different directions. When these giant plates meet, they sometimes collide or slide past each other. Imagine 2 giant puzzle pieces rubbing together. Eventually, they'll catch or get stuck, and when they suddenly move again, they cause vibrations. Those vibrations are earthquakes. So, looking at these options, what makes the most sense? If you chose B, plates sliding past or colliding with each other, you're exactly right. That's what's happening when we feel an earthquake along plate boundaries. Let's quickly talk through why the other choices wouldn't be correct. Choice A says plates cooling down and contracting. While it's true that cooling materials might shrink or contract, this process doesn't explain the powerful and frequent earthquakes we see at plate boundaries. Earthquakes require sudden, dramatic movements, not just slow shrinking or contracting. Choice C mentions plates dissolving into the ocean. Think about it. Can huge solid rock plates simply dissolve into water? Not really. Plates are solid rock, and ocean water doesn't dissolve or melt them away. So this doesn't explain why earthquakes happen. Choice D states plates expanding due to heating. Heating does cause things to expand, but the theory of plate tectonics isn't based on plates simply warming up and expanding. Earthquakes come from sudden slipping or colliding of solid rock plates, not slow expansion from heat. So, while each of these ideas might sound interesting, none of them properly explains the sudden, powerful movements we experience as earthquakes. This is why choice B, plates sliding past or colliding with each other, is the best and only accurate answer here. All right, let's look at number 2. The passage says that plants absorb sunlight through photosynthesis, converting carbon dioxide, CO2, and water, H2O, into glucose and oxygen. The chemical formula can be represented as 6CO2 plus 6H2O, then the arrow means gives off or converted to C6H12O6 plus 6O2. Then the question asks, which statement best describes the chemical equation above? What do you understand based on the passage and the question? Pause and think about it, or even make your own notes. The passage begins by talking about a process called photosynthesis. You've probably heard that word before, right? But let's refresh our memory. Photosynthesis is the process plants use to turn energy from sunlight into food they can use. The passage says plants take in carbon dioxide, CO2, that's the gas humans and animals breathe out, and water, H2O. With the help of sunlight, plants chemically change these two things into a type of sugar called glucose, C6H12O6, and release oxygen, O2, into the air. That's great news for us because we need oxygen to breathe. They've shown this chemical change using this equation. 6CO2 plus 6H2O produces C6H12O6 plus 6O2. Let's pause here for a second and look closely at this formula. You don't have to memorize it, but you do need to understand what it's showing you. Notice the arrow. In chemistry, the arrow means produces or creates. The substances to the left of the arrow, 6CO2 plus 6H2O, react together to create the substances to the right of the arrow, C6H12O6 plus 6O2. In this case, the substance to the right, 6CO2 plus 6H2O, represents carbon dioxide and water, and that produces the substance to the left of the arrow, C6H12O6 plus 6O2, which then represents glucose and oxygen. It's no different than saying 1 lemon plus a glass of water plus 2 teaspoons of sugar on the left will produce 1 glass of lemonade on the right. Does that make sense as we have explained it here? We know it can be confusing, especially if you're doing it for the first time. So pause and repeat as needed and drop us a comment if you need further explanations. Now, let's see what the question is actually asking. Which statement best describes the chemical equation above? Here are the choices given. A. Oxygen and glucose are used to create carbon dioxide and water. B. Carbon dioxide and water chemically react to produce glucose and oxygen. C. Glucose breaks down to form carbon dioxide and oxygen. D. Water decomposes into glucose and carbon dioxide. Pause again here and think carefully. What exactly is the equation showing us? Let's analyze each choice one by one. Choice A says oxygen and glucose create carbon dioxide and water. But look at the equation carefully. Oxygen and glucose are on the right side, meaning they're the end result, not the starting ingredients. So choice A doesn't match what's happening here. Choice B says carbon dioxide and water chemically react to produce glucose and oxygen. Check the equation again. Carbon dioxide and water are indeed the starting materials on the left side of the arrow, and they produce glucose and oxygen on the right side. This one matches perfectly. Choice C says glucose breaks down to form carbon dioxide and oxygen, but the equation clearly shows glucose is actually being produced, not broken down, so C doesn't fit. Choice D says water decomposes into glucose and carbon dioxide. The equation shows water involved, but it's combined with carbon dioxide to create glucose and oxygen, not decomposing into glucose and carbon dioxide alone, so D isn't correct either. After analyzing all the options, the correct answer clearly matches with choice B. Carbon dioxide and water chemically react to produce glucose and oxygen. Let's look again carefully at the equation. 6CO2 plus 6H2O, C6H12O6 plus 6O2. 6CO2, carbon dioxide, and 6H2O, water, are on the left side of the arrow. This means they are the starting materials, or the ingredients. C6H12O6, glucose, and 6O2, oxygen, are on the right side of the arrow, which means they are produced as the result of the reaction. Option B says clearly and accurately that carbon dioxide and water react chemically to produce glucose and oxygen, exactly matching what's happening in the chemical equation. In other words, option B perfectly matches the equation given, making it the correct answer. Good job thinking through this. Now, the third passage says a scientific law describes a consistently observed phenomenon, while a theory explains how or why that phenomenon occurs. A hypothesis is an educated guess that has not yet been fully tested. Then they ask, which of these best represents a scientific theory? A. Gravity makes objects fall toward Earth. B. All living things require oxygen. C. Dinosaurs went extinct due to a meteor impact changing Earth's climate. D. Water freezes at 0 degrees Celsius. It's carefully go through this passage and question step by step in a conversational way. The passage gives us 3 important scientific terms: scientific law, theory, and hypothesis. First, it says that a scientific law describes something we always see happening. It's something predictable, like water freezes at 0 degrees Celsius, or objects fall to the ground. Next, a theory explains how or why something happens. For example, a theory doesn't just say something happens. It tries to explain the reason behind it. Finally, a hypothesis is basically a prediction or an educated guess, something scientists think might be true, but it still needs testing and evidence. Now, let's look carefully at the question being asked. Which of these best represents a scientific theory? You have 4 options. A. Gravity makes objects fall toward Earth. B. All living things require oxygen. C. Dinosaurs went extinct due to a meteor impact changing Earth's climate. D. Water freezes at 0 degrees Celsius. Pause here for a second. Remember, we're looking specifically for a scientific theory, something that explains how or why something happens, not just describing what happens. Let's break down each option carefully. Option A. Gravity makes objects fall toward Earth. Gravity is something we see all the time. It describes what happens, objects fall, but it doesn't explain why gravity exists or how it works. This makes it more like a scientific law rather than a theory. Option B. All living things require oxygen. This is just stating a fact that's observed. It doesn't explain why they require oxygen, so it's more like a factual observation rather than a theory. Option C. Dinosaurs went extinct due to a meteor impact changing Earth's climate. This option doesn't just describe what happened. It explains why dinosaurs became extinct, because a meteor caused climate changes that made survival difficult. It gives a clear reason for a major event, making it a good example of a scientific theory. Option D. Water freezes at 0 degrees Celsius. This is a classic scientific law. It simply states what always happens without explaining why or how it happens. Based on what we discussed, the answer that clearly represents a scientific theory is option C, because it provides an explanation for why dinosaurs became extinct, not just describing the event itself. If you picked C, fantastic, you're understanding the difference clearly. Let's keep going. For the fourth one, they say earthquake intensity is measured on the Richter scale. A chart shows the magnitude of earthquakes and the associated energy release. For instance, a magnitude 5 earthquake releases roughly 32 times more energy than a magnitude 4 earthquake. According to the information given, how much more energy is released by a magnitude 6 earthquake compared to a magnitude 4 earthquake? Here are the answer choices. A. 32 times. B. 64 times. C. 1,024 times. D. 32,000 times. Let's take a closer look at this passage together. It mentions that earthquake intensity is measured using something called the Richter scale. Have you ever heard of that before? Basically, the Richter scale measures how powerful an earthquake is by looking at its magnitude. That means how strong it is. Now, here's something interesting the passage tells us. Each time the earthquake magnitude goes up by one number, the earthquake doesn't just get a little stronger, it actually becomes much stronger, releasing about 32 times more energy. To make that clear, the passage gives us an example. A magnitude 5 earthquake releases about 32 times more energy than a magnitude 4 earthquake. The question here asks us something similar, but it goes a step further. It asks, how much more energy would a magnitude 6 earthquake release compared to a magnitude 4 earthquake? Pause here for a second and think carefully. If going from magnitude 4 to magnitude 5 releases 32 times more energy, what happens when we move up 2 numbers, from 4 to 6? Well, we know moving from magnitude 4 to magnitude 5 is already 32 times stronger. Then going from magnitude 5 to magnitude 6 would again be 32 times stronger. That means we multiply by 32 2 times. 32 times 32, and 32 multiplied by 32 equals 1,024. So if you chose answer C, 1,024 times, you're exactly right. A magnitude 6 earthquake releases about 1,024 times more energy than a magnitude 4 earthquake. All right, let's talk chemistry. But don't worry, we'll keep it simple. Passage 5 says that in chemistry, substances react to form new substances. The reaction is indicated by an arrow, and the combination of substances by a plus sign. Have you already written down the question? In the chemical equation sodium plus chlorine, then they give you the arrow, and then finally, sodium chloride. What do you think the arrow indicate? Is it A, where they say Na and Cl will separate from each other, or is it B, where they say Na is added to Cl? C says that Na and Cl combine chemically to form a new substance, and the final option is that Na and Cl remain unchanged after interaction. Now, chemistry is all about how different substances react, and combine to form completely new substances. Chemists write these reactions down using chemical equations, kind of like recipes. Remember that the arrow has a very specific meaning. It shows you what substances are produced as a result of the reaction. The substances on the left side of the arrow are the ingredients, or what you start with, like our lemonade example, and the substance or substances on the right side are what's created after the reaction takes place. If you were baking a cake, you would expect to see flour and eggs and baking powder on the left of the arrow, and on the right, you would expect to see a cake. Now, let's look at the equation the passage gives us: sodium plus chlorine, and then our famous arrow, and finally, sodium chloride. Here, Na stands for sodium and Cl stands for chlorine. When sodium and chlorine react chemically, they create sodium chloride, which you might know better as regular table salt. So now, looking at the question, it asks specifically, what does the arrow indicate? Let's consider our options carefully. Option A says the substances sodium and chlorine separate. But that's not right, because we know they're actually coming together, not separating. Option B suggests something different, but it's not quite right either, because it doesn't clearly explain that a new substance is being made. It just talks about combining them without emphasizing the formation of something new. Option D isn't correct either, because it doesn't describe what's happening properly. But option C is exactly right. It matches the meaning we discussed. The arrow means that sodium and chlorine chemically react and combine, creating a brand new substance, sodium chloride. Did you pick that one? Great job if you did. Let's keep going. Let's move forward and take a look at the next passage. First, I'm going to read the passage and the question carefully, and then we'll talk about it together, breaking down the ideas and concepts step by step. The passage says, "A climate chart indicates average annual temperatures increasing over the last several years." Then it gives you a question. Which statement best describes what this information suggests? Option A, average temperatures are increasing because fossil fuels reduce temperatures. Option B, Earth's temperatures have risen due to increasing carbon dioxide from fossil fuels. Option C, temperatures naturally fluctuate, so fossil fuels don't affect climate. Option D, increased fossil fuel use is causing global temperatures to fall. All right, now let's slow down and unpack what we just read. The passage mentions a climate chart, which is a visual tool scientists use to track changes in Earth's climate, especially temperature changes over time. This particular chart showed something really important. Average annual temperatures have been rising over recent years. Why might this be happening? Well, scientists have pointed out that increased use of fossil fuels, like coal, oil, and natural gas, produces a lot of carbon dioxide. You've probably heard about this gas before. It's often called CO2, and it's one of the main greenhouse gases. Greenhouse gases trap heat in Earth's atmosphere, much like how a greenhouse keeps plants warm. Now pause here for a moment and reflect on this concept. If fossil fuels release carbon dioxide and carbon dioxide traps heat, what might this mean for Earth's temperature? The question we're looking at is really asking, what is the main message of the passage? It's checking if you understand the relationship between fossil fuels, carbon dioxide, and climate change. Let's go through each of these answer choices together, thinking carefully about whether each one fits what we've discussed. Option A says fossil fuels reduce global temperatures. Does this make sense based on our passage? Actually, no. We just talked about how fossil fuels release carbon dioxide, a gas that traps heat. So fossil fuels aren't making Earth cooler. Let's rule out option A. Option B suggests Earth's temperatures have risen because carbon dioxide from fossil fuels is increasing. Does this seem right? Think carefully. This matches exactly what the passage explained. Fossil fuels produce CO2, trapping heat and warming the planet. So hold on to this one. It sounds correct. Option C states that temperatures fluctuate naturally and that fossil fuels don't impact climate. It's true that Earth's temperatures do change naturally sometimes, but remember, the passage specifically mentions temperatures increasing in connection with fossil fuel use and carbon dioxide emissions. So this option doesn't align with the information we have. Option D claims fossil fuels cause global temperatures to fall. Again, is that what the passage described? No, it's exactly the opposite of what we've learned. Fossil fuels actually increase temperatures because of carbon dioxide emissions. Pause here and take a moment to reflect on what we've talked about. Which of these answers fits best based on what we've discussed? If you selected option B, that Earth's temperatures have risen due to increased carbon dioxide from fossil fuels, excellent job. You're exactly right. This option clearly matches what the passage explained to us about carbon dioxide emissions causing higher temperatures. Great analytical thinking. Let's keep that energy going into the next question. All right, let's dive right into passage 7. First, I'll read the passage and the question along with the answer choices, and then we'll slow things down, break it apart, and understand exactly what it's asking us to think about. As always, stay active in your thinking as we go along. Here's the passage. In biology, a cell membrane allows certain substances to pass through but blocks others. This characteristic is called selective permeability. And here's our question. The selective permeability of cell membranes is most beneficial because Option A says it allows all substances to enter the cell. Option B says it blocks all substances from entering the cell. Option C says it enables cells to control their internal environment. Option D says it removes all toxins immediately from the cell. Now, pause here for just a moment and think carefully. What exactly is this question asking us? It's asking us to think about why selective permeability, allowing some things in but not others, is beneficial to the cell. First, let's make sure we clearly understand the idea of selective permeability. Imagine a cell as a tiny protected space that needs certain substances to survive, things like nutrients or oxygen, but it also needs to keep harmful substances out. The cell membrane acts like a very careful security guard at the entrance. It doesn't let just anything enter or leave. Instead, it selectively decides, this substance can enter, but that one can't. Now, why is this ability so important? Think of your own body. Imagine if your skin allowed absolutely everything to enter. Harmful chemicals, dirt, or anything else it touches. That wouldn't be safe, right? Similarly, a cell needs to carefully regulate its internal environment to remain healthy and functional. Now let's take a closer look at the answer choices one by one and think through them carefully together. Option A says the cell membrane allows all substances to enter. Does that sound right to you? If the cell membrane allowed everything in, it wouldn't be selective at all. It would risk the cell's health by allowing harmful substances in along with the good ones. So, option A doesn't quite fit. Option B says it blocks all substances from entering. Think about this for a moment. If the cell blocked everything, even essential nutrients couldn't get in. That wouldn't be helpful either because cells need certain materials to survive. Option B doesn't work either. Option C says it enables cells to control their internal environment. Think carefully. Is this what selective permeability really does? Actually, yes. It allows the cell to decide exactly what substances to let in or keep out, keeping its internal environment balanced and safe. Option C sounds exactly like what we've been discussing. Option D suggests it removes all toxins immediately from the cell. While removing toxins is certainly beneficial, selective permeability doesn't automatically remove all toxins. It mainly controls what enters or exits. It's not an immediate detox system, so this option isn't correct. Now, take a moment here. Pause, reflect, and consider carefully. Which option aligns perfectly with our explanation of selective permeability? If you picked option C, that selective permeability enables cells to control their internal environment, excellent work. That's exactly right, because the cell membrane carefully controls what enters and exits, keeping the cell healthy and stable. Great analytical thinking. Let's move forward to the next question. All right, let's jump into passage 8 together. First, I'll read the passage, the question, and the possible answers. Then we'll slow down, break it apart, and really think through what each part means. Be sure to stay active in your thinking, reflecting as we go along. Here's the passage. Graphs of ocean salinity levels show increased salt concentrations in certain regions. Higher salinity is often due to greater evaporation rates caused by higher temperatures. And here's the question. Based on this information, regions with higher ocean salinity are likely to experience Option A, frequent rainfall. Option B, higher temperatures. Option C, reduced evaporation rates. Option D, significant freshwater inflows. Now, pause right here. Before you choose an answer, let's carefully make sure we understand what's going on in the passage. The passage mentions something called salinity, which simply means how salty the water is. Think about what happens when ocean water evaporates. When water evaporates from the ocean's surface, it leaves behind salt, making the remaining water saltier. Evaporation often happens faster in places with warmer temperatures, because heat makes water evaporate more quickly. So the key concept here is the link between temperature, evaporation, and ocean salinity. Let's quickly summarize that idea again clearly. Higher temperatures cause more evaporation. More evaporation leaves behind more salt, increasing salinity. Now that we understand that, let's look again at our question. It's asking us to use this information to figure out what conditions a region with high ocean salinity might have. Let's think carefully about each answer option together, one by one. Option A says frequent rainfall. Now think carefully. Rainfall adds fresh water to the ocean, diluting the salt and reducing salinity. Would that result in higher or lower salinity? Definitely lower. So option A probably doesn't match. Option B says higher temperatures. Now, reflect back to what the passage said. It specifically mentioned higher temperatures causing increased evaporation, which then leads to higher salinity. Does option B make sense based on what we learned? Yes, it seems to fit very clearly. Option C states reduced evaporation rates. Pause here and think. Would reduced evaporation cause more salt to remain or less? If there's less evaporation, less salt would stay behind. So reduced evaporation would actually lower salinity. That means option C doesn't match our passage. Option D says significant freshwater inflows. Freshwater coming in would make the ocean water less salty, right? It would dilute the ocean water and decrease salinity. So that's not correct either. Now pause again and take a moment to reflect. Which of these options clearly matches what the passage explained? If you selected option B, higher temperatures, you're exactly right. Because higher temperatures mean more evaporation, and more evaporation means higher salinity, this option perfectly aligns with the information we've just analyzed. Excellent thinking. Let's keep going. All right, let's go through these next two passages together. We'll read each passage carefully, look at the question and choices, then slowly analyze what each part means. Remember, take your time to pause, reflect, and really think actively as we move through. First, let's read passage 9. A visual chart compares the effects of two fertilizers on plant growth, measured by plant height over time. Fertilizer A shows consistent plant height increases, while fertilizer B results in less predictable and varied results. And here's the question related to this passage. Which conclusion about the fertilizers is most accurate? Option A, fertilizer B is more reliable than fertilizer A. Option B, fertilizer A consistently promotes plant growth. Option C, both fertilizers produce equally reliable results. Option D, fertilizer prevents growth variability. Now pause right here and think about what's happening in this passage. We're looking at a comparison between two different fertilizers. Fertilizers are substances used to help plants grow. The passage tells us fertilizer A leads to consistent increases in plant height. This means whenever fertilizer A is used, the plants steadily grow taller over time. Fertilizer B, however, gives us results that are varied or unpredictable. That means sometimes the plants grow taller, and sometimes they don't grow much at all. The question asks us to figure out the best conclusion we can draw from these results. Think for a moment. What does consistent mean in terms of reliability and predictability? Let's break down the answer choices one by one to clearly understand which one is correct. Option A says fertilizer B is more reliable. But remember, the passage said fertilizer B's results were varied and unpredictable, meaning it is definitely not more reliable. So option A isn't correct. Option B states clearly that fertilizer A consistently promotes plant growth. Think carefully about the word consistent. It matches perfectly with the description we read. Fertilizer A always produces steady growth. This sounds like a good match. Option C suggests both fertilizers produce equally reliable results. Based on what we read, is that accurate? Fertilizer B was described as unpredictable, so they're definitely not equally reliable. So we can safely set option C aside. Option D says fertilizer. A prevents growth variability. This option is tricky. Does fertilizer A actually prevent growth variability, or does it just produce consistent results? It's not necessarily preventing variability. It's simply more consistent. So option D isn't the best answer. Pause again and reflect carefully. Which answer most accurately matches the information we have? If you selected option B, that fertilizer A consistently promotes plant growth, then you're exactly right. Fertilizer A reliably helps plants grow at a steady rate, according to the data provided. Great job! Now let's look at passage 10. Atomic symbols represent chemical elements. For instance, Fe stands for iron, O stands for oxygen, and Na stands for sodium. Atomic symbols are used universally to simplify scientific communication. Here's our question for this passage. Why do scientists primarily use atomic symbols instead of full element names? Option A, to make scientific communication simpler and clearer internationally. Option B, because element names change frequently. Option C, to hide the true identity of chemicals. Option D, atomic symbols describe the properties of elements directly. All right, pause here for a moment and think. What exactly is this question asking us to consider? The passage explains that scientists use atomic symbols, short abbreviations, for elements. For example, Fe for iron, O for oxygen, and Na for sodium. Why might scientists prefer these short symbols over using the full names of elements? Let's examine each answer carefully and think through them. Option A says it makes scientific communication simpler and clearer internationally. Think about this. Scientists all over the world speak different languages, but the symbols Fe, Na, or O mean the same element to everyone, no matter their language. Does this seem like a reasonable purpose for using symbols? Yes, definitely. Hold on to this one. Option B claims that element names change frequently. Pause and consider. Do element names really change often? Actually, no. Element names remain quite stable once established, so option B doesn't seem right. Option C says it's to hide the true identity of chemicals. Ask yourself, why would scientists want to hide the identity of common chemicals like iron or oxygen? That doesn't make sense scientifically. Scientists aim for clarity, not secrecy. We can cross out option C. Option D suggests atomic symbols describe properties of elements directly. Think carefully. Does Na or Fe actually tell us directly about their properties, like how they behave or their appearance? Not really. The symbols simply stand for names. They don't describe properties clearly by themselves. Pause and reflect again. Which answer best fits the explanation the passage gives? If you chose option A, that atomic symbols simplify scientific communication internationally, you've done excellent analytical thinking. Using symbols ensures scientists everywhere clearly and quickly understand each other, regardless of their language. Great job staying with me through each question. I hope you're feeling more confident in your ability to tackle these kinds of GED-style questions. Now it's your turn. Drop a comment below and tell me which question you found most challenging and why. Did any particular strategy or thought process help you figure it out? Also, I'd love to know which questions you got right and how you approach solving them. Your experiences help everyone in our learning community. If you enjoyed this video and found it helpful, please give it a thumbs up, and don't forget to subscribe to the channel so you won't miss any future GED tips and tutorials.